All right, so we are going to start doing some word problems that involve quadratics. I'm going to use a Desmos to do a lot of these. In class, I'll do Desmos, but I'll also do the graphing calculator. So we need to, especially if you're in my class, know how to use the graphing calculator on this. All right, we talked about this the other day. Most of these problems, the leading coefficient, the A, is negative. If A is negative, the parabola is going to open downward, meaning you are going to have a maximum point here, and you also might have a spot where the parabola hits the x-axis there, all right? If A is positive, sometimes they do have these, the parabola is going to open that way, okay? Most of these problems are the same. So if I draw my x and y axis, majority of these problems take place in quadrant 1. They are downward facing, and they look somewhat like this. The key components to these problems are the y-intercept, that's also the c, that's that point right there. The highest point, both x and y coordinate, remember the x coordinate is the axis of symmetry, the y coordinate is normally the height, and this solution root 0, x-intercept, whatever you want to call it, right there. Usually that's when whatever the object is hits the ground, okay? And again, I'm going to graph them. I'm going to switch back and forth on these and just talk about these things. So if we look at problem number 1, during a halftime in a basketball game, a slingshot launches T-shirts at the crowd. This is demonstrated by the function h equals negative 16t squared plus 72t plus 5, where h is the height and t is the time. Now, what's happening here, you do not have x and y. Y is now h, which is height. X is now t, which is time, in seconds, okay? Since A is negative, I can clearly see that right here, and I see the y-intercept is 5, my graph is going to look something like this. Now the question says, how long will it take the t-shirt to reach its maximum height? That is the x-coordinate of the vertex. What is the maximum height? That is the y-coordinate of the vertex. So what I'm going to do is go to Desmos and type this in. So we can see what this looks like. Again, you don't have an H and a T button. You do have a Y and an X button. So Y equals negative 16 instead of T. We're going to do X squared plus 72X plus 5. And again, Desmos is kind of easy. You can just scroll till you get it. But what I was looking for was the time it takes for that t-shirt to reach its maximum height. That should be 2.25 seconds. And then question number 2 said, what is the maximum height? That should be 86 feet. The y-coordinate is your maximum height. The x-coordinate is the time. If the question said, how many seconds does it take for the t-shirt to hit the ground, assuming nobody caught it, that would be your 0, x-intercept, solution, root, whatever you want to call it. That would be 4.568 seconds. All right, that's not what they asked, but that's what another question could have been. Okay, so what was the time it took to reach the maximum height? That was 2.25 seconds. What was the maximum height? That was the y-coordinate. That was 86 feet. That's all you're doing, okay? And again, in class, I'll show you how to do it this way and with the graphing calculator. All right, number 2, suppose a tennis player hits a ball over a net. The ball leaves the racket 0.5 meters above the ground. Here is my equation. They will always give you the equation. I see a A, a B, and a C. It looks to me like A is negative, so this is going to open downward. And it also shows me that C is 0.5. All right, that gives the ball height in h meters after t seconds. What is the axis of symmetry? Remember, axis of symmetry is the x-coordinate of the vertex. So that would be the x-coordinate of the vertex. When will the ball be at the highest point in its path? Okay, so we're also looking for the actual highest point here. So that'll be the y. Okay, so same thing. I'm just going to go and graph it real quick. So I'm going to go to Desmos. This one's not going to be that far off the ground. So same thing. I'm going to hit y equals. And it's negative 4.9 x squared plus 3.8 x plus 0.5. And there it is right there. So what it's showing to me is the axis of symmetry is 0.388, and the ball was at its highest point. I'm going to take it two places. Would be at 1.24, and this problem was in meters, not feet, so it'd be 1.24 meters is when it was at its highest point, okay? If it said how many seconds did it take for the ball hit the ground, that answer would be 0.89 seconds. It didn't ask that question, but it very easily could have. All right, so axis of symmetry on this problem was x equals 0.388. When was the ball at its highest point? 1.24 meters. All right. Here's another one. In the shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be modeled by the equation. There's your equation. That's another quadratic. I see a B, and a C. I'll also see a that's negative. X is the horizontal distance. So this one's a little bit different. X is not time. X is actual horizontal distance. So how far out this person throws it. And y is still the height. All right, so y is the height this time. What is the maximum height of the ball? How far from the athlete will it land? So this one's a little bit different. I see the y-intercept is 2. So this person actually releases it. Looks to me like it is 2 meters off the ground. So then it goes up in the air, hits a high point, and then it comes back down. This time we're trying to find the maximum height of the ball. That's the y-coordinate. How far from the athlete will the ball land? We're actually finding this spot right here because x is horizontal distance. So let's go look at our answers. We can type it in real quick, clear off the old one. So this time it's going to be y equals negative 0.04 x squared plus 0.84x plus 2. Okay, they must have released it 2 meters off the ground. And which one of these numbers is the height? 10.5 or 6.1? Or 6.41? 6.41 is the actual height. And then the other question said, remember, x is not time this time. X is horizontal distance. How far did he throw it? I'm going to take it two places. That'd be 23.16, all right, meters, 23.16 meters. All right, so that's how far he threw it. And again, the highest point it ever reached was 6.41, all right? All right. So what was the height? Height was 6.41. How far from the athlete will the ball land? We said that answer was 23.16, all right? All right, last two. A scientist records the motion of a dolphin as it jumps from the water. Here's the function. Now this time I only see an A and a B. I don't see a C. Well, that must mean that C must be 0. Well, that makes sense. The dolphin must have jumped out of water, hit a high point, and then landed back in the water. All right? All right, it models the dolphin's height in feet above the water after t seconds. So this time the x-axis is time, and the y-axis is height. What is the dolphin's maximum height? That's the y-coordinate of the vertex. How long is the dolphin out of water? So what we're trying to figure out is the time from here to right here when he lands. So I'm also finding that 0 again. All right. All right, same thing. I'm just going to type them in real quick. See what we get. Clear this one. All right, y equals negative 16 x squared plus 32x. And there we go right there. So negative 16 x squared plus 32x. What was the dolphin's maximum height? Should have been 16 feet. How long was the dolphin out of water? Should have been 2 seconds. When he landed back in water, the time was 2 seconds. All right? So again, it's always asking the same questions for the most part. All right, so what was the dolphin's maximum height? We said 16 feet. And how long was he out of water? 2 seconds. All right, this last one's a good question. The height above water level of a curved arc support for a bridge can be modeled by, again, there's my problem. I see an A, a B, and a C, and I see that A is negative. All right, where X is the distance in feet from where the arch support enters the water, can a sailboat that is 24 feet tall pass under the bridge? So what we have is water, and we also have this arched bridge, and we need a sailboat that can try and pass under it. So the sailboat is 24 feet tall. A tugboat is 30 feet tall. We want to see if they can both fit under the bridge. So what we really need to see is what is the maximum height of this curved bridge. All right. All right, so I'm finding the y coordinate here. So again, I'm going to go and type it in real quick and see what we get. Clear this one off. Same thing, y equals, this time it's negative 0.007x squared, all right, plus 0.84x plus 0.8. And again, you might have to zoom it out a little bit, but there it is right there, all right. What we were trying to find is the maximum height of the bridge. So it looks to me like the maximum height of the bridge is 26 feet. So let's go back and look at our questions. If this bridge is only 26 feet high, so we know that this bridge is 26 feet high, that means the highest point down to the water is 26 feet. Can a sailboat that's 24 feet tall pass? Yes. Can a tugboat that's 30 feet make it under the bridge? The answer would be